Hello everyone, hope all of you are fine. Today I came in front of you with one very important topic, that is electricity. In that MCQs, short answer type, long answer type, all the different type of questions, case study question, everything we will discuss today. It will help you definitely in your final exam to know which type of questions will come and how to solve them. And as I said before, subscribe the channel, share the video, like it so that it will reach to many of your friends. Now let us enter into our topic, that is electricity. In electricity, first we will discuss some MCQ type of questions. So here first question is what we have to match it. What we have in this, we have electric current, all the different type of physical quantities we have and their units we have. What is the unit of electricity? Unit of electric current is ampere. EMF, unit of EMF is volt, and resistance is ohm. Resistivity is ohm meter. So what our option should be? A4, B1, C2. A4 we have here in B and C also, but we want A4, B1. A4, B1 is option C. So this is what? Correct option. So you need to know all the physical quantities and their units. Electricity amperes, electric current amperes, EMF volt, resistance ohm, and resistivity is ohm meter. Now coming to second one, which of the following obeys Ohm's law? You know Ohm's law, hope everybody know Ohm's law, that is potential difference is directly proportional to current. This law will be followed by some conductors, and some conductors they do not follow this law. So the conductors which do not follow, we call them non-ohmic conductors, and which follow we call it as ohmic conductors. Generally all semiconductor devices, diode, transistor and LED, filament of a bulb, all these are non-ohmic conductors. So we have only one option, that is nichrome. Nichrome is a ohmic conductor which obeys Ohm's law, and these three do not follow Ohm's law. Question number 2. Now question number 3. An electric bulb is rated 220 volt, 100 watt. Voltage of the bulb is given, power of the bulb is given, we have to find out resistance. There are two methods. One is you can use the formula P is equal to V into I, but in this we do not know I, so first we have to find out I. Or another one, we also have P is equal to V square by R. So here V is given, what we have to find out? R we have to find out. V is given, power is given. So by using this formula we can find out R. P is equal to V square by R. From this, P is how much it is given? 100 watt. 100 watt is equal to voltage, how much it is given? 220 volt. 220 square by R. Now we have to transpose these two. We want R, so R we should send here. 100 we have to send there. Then we get R is equal to 220 into 220 by 100. So that what happens? 0, 0, 0, 0 will be cancelled. 22 into 22, 484. R is equal to 484 ohms. So what is the correct option? Option D is correct. 484 ohms is correct. Hope that one you understood. Now coming to question number 4. Here what is happened in this? The resistance of a conductor is R. The length is doubled by stretching the wire. Then its new resistance will be. Generally we have here resistance depends on length of the conductor, directly proportional to length, and resistance is inversely proportional to A, area of cross section. So here, because they did not mention anything about area, we think it is directly proportional to L. Since length is doubled, resistance also it will be double. Okay, that is fine. But here how it is made double is important. By stretching. When you stretch the wire, what happens? Length will be increased, at the same time thickness will be decreased. Length will be increased and thickness will be decreased. So when thickness is decreasing, what we should understand? Area is getting decreased. Area is made half. Okay, area will be half. So what happens here? We have to take. So R is equal to, we will be having formula rho into L by A. This is in the first case. But in the second case, let us take it as R2 or RL. What happens? Rho into L we have to substitute as 2L. But what happened to A? It made half. In the second case, A is half. So you have to take it as A by 2. Now overall it will be rho into 2L into 2 by A, because this A by 2 will become reciprocal. Now it becomes rho into 2 into 2, 4 into L by A. That is 4 into rho into L by A. Now what is rho into L by A? Rho into L by A is R only. So what it is? 4 times R. If it is subjective, we have to write like this. But if it is objective, what you have to do? You have to remember, when length is increased, resistance will be increased. When area is decreased, resistance is also increased again. So here area becomes half. So resistance will be 2 times, it will be increased. So you have to remember that 4 times. For length 2 times, for area, because area is decreased, area is resistance is doubled again. 2 times it will be 2 times for length, 2 times for area, total 4 times it will be increased, 4R. Now coming to next question, you have to observe this graph, and in this you have to decide which is correct. In all these cases, what happens? Everywhere this is what voltage, this is what current. What we have to do, in every case we know one formula, R is equal to V by I. So if you want to know where resistance is more, where resistance is less, you need to know where voltage is more. Where voltage is more, there resistance will be more. In case of R, if you observe, voltage is more, current is less. When voltage is more, current is less, resistance will be more. So R3 will be more. Why? Because voltage is more. R3 is what? R3 is greater. Then if you observe second one, voltage is medium, current is also medium. So it will be there in the middle. Resistance R2 will be in the middle. Coming to third one, voltage is less compared to first two and current is more. In this case, what happens? Resistance will be less. So R1, this is what correct option. Only one thing what you have to remember, where voltage is more, their resistance will be more. So which option is correct? Option B is correct. Now coming to next one, it is assertion and reasoning. Alloy are commonly used in electrical heating devices like electric iron and heater. Yes, in all the heating devices, generally we use alloys. So assertion is true. Resistivity of an alloy is generally higher than that of its constituent metals. But alloys have low melting point. So this is wrong, because alloys will be more strong than individual metals and its melting points will be high. So here assertion is true, reason is false. Option C will be correct. Option C is correct. So hope you all understood about these MCQs and assertion and reasoning. These are some sample questions how they are going to come in your final exam from electricity. Now let us see some short answer type questions from electricity, how they will. Short answer type 1. First question, First question, what it is given? Draw a schematic diagram for a circuit in which three resistors R1, R2 and R3, plug key and ammeter are joined in series with a 5-volt battery. Also a voltmeter is connected to measure the potential difference across the R1. So this diagram we have to draw. So here, to show here I am drawing in this space, I am drawing the answer for the question number 7, the diagram. So here we need three resistors in series, R1, R2, R3 are in series. Then these three resistors should be connected to a 5-volt battery, positive series of cells like this. This is battery. Now we need one plug key also, because they mentioned plug key, and then ammeter should be connected in series. So here ammeter in series, then close it. But they mentioned one voltmeter also across R1. Voltmeter should be connected in parallel. It is very important. Remember, ammeter in series, voltmeter in parallel. So what? Voltmeter in parallel with R1, because we want to measure voltage across R1, potential difference across R1 we want. So I am writing this is R1, R2, R3. So all are mentioned in this. All the three resistors are connected in series. Voltmeter across R1, 5 volts battery, plug key, ammeter. This is positive, this is negative. Then again positive, negative. Again here what? Positive, negative in series. So after this what? Current direction, positive to negative. This is what current direction. So like this, you have to draw the schematic diagram according to the given information. Hope you understood how to draw. It is a very simple one. You should know how to connect in series, how to connect in parallel. Ammeter should be connected in series, voltmeter should be connected in parallel, along in which resistance you want to find out the potential difference to that resistance you have to connect in parallel. This is done. Now coming to next question, calculate the equivalent resistance of the following electric circuit. So already electric circuit is given. You have to find out equivalent resistance in this circuit. So here what we have to do, first we have to take this part from here to here. That part if you take, they are in series. So let us take, this is R1, R2, R3, R4 and R5. So in first case what happened, R2 and R3 are in series. So I am finding that effective resistance, R effective of what? 2 and 3. I am representing like this. So that is what, they both are connected in series. So what it is, R2 plus R3, which is nothing but 10 plus 10, because they are connected in series. R2 plus R3 formula, 10 plus 10, 20 ohms. Now this 20 ohms, now this has become single resistance of resistance 20 ohms. Now this single resistance 20 ohms is in parallel with another 20 ohms. These two we have to find out. They both are in parallel. So now effective resistance of what? R4 and what it is, R23 you can write. So that is what 20 I am writing directly. We cannot write like this. What? 1 by R234. Let us write it as 234 is equal to what? Effective resistance of 234 now. That is 1 by 20 plus 1 by 20. 1 by 20 plus 1 by 20 is 2 by 20. 2 by 20 is 1 by 10. So finally we get that effective resistance, R effective of these three will be 10 ohms. Now this part is completely over. That complete part we got just now, we can represent it with a single resistance. So we will be having like this now. 10 ohms here. Again, this is what effective resistance, 10 ohms only. And later we have 20 ohms. So 10 ohms, 10 ohms, 20 ohms. Now these three are in series. So how can we find out effective resistance of these three? I am writing here now effective resistance is what? They are in series 10 plus 10 plus 20. So overall it is 40 ohms. So overall effective resistance of that circuit is what? 40 ohms. First I found these two, 10 plus 10, 20. Then I found this 20 and 20, they are in parallel, 1 by 20 plus 1 by 20, 2 by 20, 1 by 10, effective resistance is 10. Then this is 10, this is 10, this is 20, 10 plus 10 plus 20, 40 ohms. Hope you understood how to find out it. If they ask you to find out current, voltage is not given, we cannot find out, only effective resistance they are asking to find, we got it. Hope you understood that. Now coming to this, question number 9. In question number 9, what happened? They are asking how much power is dissipated in the circuit when all the three bulbs glow together. Now all the three bulbs are connected in parallel. So what happens here? Here I1 will be there, I2 will be there, I3. But when they come here, I1, I2, I3, all the three together, it will become again I. I is equal to I1 plus I2 plus I3. So that I is given, total current is given. Why it is total current? Because when all the three bulbs glow, current of 3 amperes is recorded. Means what? Total current is recorded 3 amperes in ammeter. How much power is dissipated in the circuit? Total voltage is given, total current is given 3 amperes. So what is the power formula? Power is equal to V into Y. Power is equal to V into Y. So nothing but 4.5 into 3, which is 13.5 watt. That is not amperes, 13.5 watt it is. Units of power is watt. So 13.5 watt. Overall power. Next question, study the following circuit and answer the following questions that follows. First question, how much current is flowing through 10 ohms? Here there are two resistances. Let us take the first one R1, second one R2. R1 is given 10 ohms, R2 is given 15 ohms. They both are connected in parallel. When both are connected in parallel, there will be different currents. They are asking to find out current only. So what I1 we have to find out. What is I1? Generally I is equal to V by R. I is equal to V by R. Now we can write V by R1. V is 4. V is how much it is given? V is given 3 volts it is given. V is 3 volts. So what it is? 3 by R1 is 10. So what it is? 0.3 ohms. This is what I1. Now coming to I2. I2 is equal to again V by R2. In parallel, potential difference is same. So that is 3 by R2 is 15. 3 by 15. 3 by 15 is what? 1 by 5. 1 by 5 is 0.2 ohms. So that is I1, I2. We want what is the ammeter reading. So when it comes ammeter, again what happens? They both will be mixed. I1 plus I2 it will be. Ammeter reading will be I1 plus I2. So I is equal to 0.3 plus 0.2, total 0.5 ohms. This is what ammeter reading. Hope you understood this also. Now next, all these are some simple questions only. If you want more difficult questions how to solve, you can comment in the down if you want. I will make one more video only numericals, electricity only numericals, in what way we have to solve. We will discuss in another video if you want. For the next one, write the formula for determining the equivalent resistance between A and B of the two combinations. One is in the first one and the second one. You can observe clearly in the first one they are in series. In series, effective resistance formula is what? R is equal to R1 plus R2 plus R3. And the second one is parallel. In parallel, we use the formula R is equal to 1 by R is equal to 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That's it. So this you have to remember. Now the next one, if the equivalent resistance of the arrangements 1 and 2 are RS and RP respectively, then which of the following graphs is correctly labeled? Justify your answer. So what happened? This is what RS it is given, effective resistance. Here it is given RP, effective resistance. So if these two are effective resistances, then which graph is correct? As I said before, resistance is equal to V by I. Where voltage is more, their resistance will be more. And according to series and parallel connection, what happens? Always resistance in series connection will be higher than resistance in parallel connection. This we have to keep in mind. So resistance in series connection should be higher. Means what? Where RS is there VI should be more. So if you see in first figure, this is V, this is I. So here V is more. So see, V is more here. V value is more. Here V value is more. And here V value is less. So what happens? Where V is less, there resistance will be less. So according to this, we have correct, because for RS V by I is more, because their voltage is more, current is less. Voltage is more, current is less means what? RS is more. And here current is more, voltage is less, RB is less. RS is greater than RP should be satisfied. That is satisfied in the first figure. In the second figure, what is happening? RP is more, RS is less. Here what is happening? RP is more than RS, which is false. In the first figure, RS is greater than RP, this is true. So in the first figure it is correct. Now coming to 12th question, define the term electric power. How do you define a power? Generally, rate of doing work. But in electricity, rate of consumption of electrical energy. Rate of consumption of electrical energy will be called as power. What is the power formula? Power is equal to V into I. This is the power formula. But here what we have to derive? Derive an expression for the power in terms of resistance and voltage. Then what you have to do? We know I is equal to V by R. Because in formula we should have only voltage and resistance according to the question. So this I must be replaced by V by R. So we get P is equal to V into V by R. V into V by R is what? V square by R. So the final derivation is what? P is equal to V square by R in terms of V and R. Power formula in terms of V and R. And at last there is one problem also in this. What is the power of a device of resistance 400 ohms and the voltage 200 volts? So which formula we have to use? Same formula. P is equal to V square by R. That is 200 into 200 by R is 400. So cancel 0, 0, 0, 0. 4 ones are 4 ones are. So what is left over? 100. So 100 watt. Power is what? 100 watt. Hope you understood this also. Coming to next question, long answer type it is. What it is given in this? Two identical resistance, each of resistance 15 ohms are connected in series in first case, in parallel in the second case, to a battery of 6 volt. Calculate the ratio of power consumed. So almost many problems are related to what? Power. Now let us do it on the board, because it is a big problem. I think it will be better if I write on the board, you will understand better. So in the first case, what happened? Two identical resistance, each of 15 ohms, are connected in first case series. So in the first case, 15 ohms R1 and R2 is also 15 ohms. These two are connected in series. Then what is overall resistance? Final resistance will be R is equal to R1 plus R2, that is 15 plus 15, 30 ohms. Okay, effective resistance is 30 ohms. And we want power. Power is equal to V square by R. What it is given? Given V is equal to, given V is equal to 6 volt. So according to the question, 6 square by R is what? 30. So that is what? 36 by 30. Let it be 36 by 30 watt. We can cancel it, but let us keep like that only. This is power 1 in the first case. Power 2 in the second case. Again, effective resistance we have to find. 1 by R is equal to 1 by R1 plus 1 by R2. Why? Because they are connected in parallel. So what we get here? 1 by 15 plus 1 by 15, which is 2 by 15. So R is equal to 15 by 2. That is 7.5 ohms. Then again same formula, power formula is what? P2 is equal to V square by R effective. That is what? Again 6 square by 7.5. 6 square is 36. 36 by 7.5. So what we get here? These two we got. Now we have to find ratio of powers. In the question they are asking to find what? They are asking to find long answer that calculate the ratio of power consumed in the combination of resistors in each case. So we have to find P1 by P2, that is 36 by 30 by 36 by 7.5, which is nothing but 36 by 30 into 7.5 by 36. 36 will be cancelled. So finally it will be 7.5 by 30, 75 by 300, 4 times exactly. So what it is? P1 by P2 is equal to 1 by 4. So this is the ratio of powers consumed in each case, powers dissipated in each case, power consumed in the combination of each case. Okay, this is done. Now next case study question is there. One case study question is there. In this case study question, everything information is given about Joule's law of heating effect. H is equal to I square R T. And the electrical fuse, electrical heater, electric iron, electrical geyser, all these follow this Joule's law of heating effect, or based on heating effect of current. So now what we have to find? What are the properties of heating element? This is what, in what way that conductor should be there, that machine should be there, what are the properties of that heating element so that it will produce more heat. What it should have? First point, that element should have high resistance to produce more heat, high resistance. And the second is what? High melting point, very important. These two qualities, these two are the properties of a heating element to produce heat in the device. It should have high resistance so that more heat will be produced, and it should have high melting point so that even though more heat is produced, it will not melt. It will not melt, but it will produce the heat. So these two are the properties of heating element. You have to remember. Next one is what? what are the properties of electric fuse? So here electric fuse, what happens? High resistance it should have, high resistance, and low melting point, These are the properties of fuse. Why it should have low melting point? Because when high resistance is there, high amount of heat it will produce. Because of that heat produced in the fuse, it will melt because its melting point is low. So when it reaches this melting point, automatically that fuse will melt. When it melts, circuit will be open. When circuit is open, that current will not allow into the current will not enter into the home. So remaining all devices will be safe. So a fuse should have high resistance and low melting point, and other heating elements which are used in all these electrical appliances should have high resistance and high melting point. Now question number 3 in this is 1, 2, 3 in case study. What they are saying, when the current is doubled in a heating device, and the time is halved, what will be the heat energy produced? So let us take A1 is doubled, A and A2 is 2A. In the first case it is A, but in the second case it is doubled. Similarly, what it is halved? Time. T1 is equal to T, but T2 is equal to T by 2, half. Now what they are asking, what will be the heat energy produced? Generally heat energy produced is what? I square R T. Okay, I square RT, but I took here current as A1. Actually you can take it as I1 and I2. If you take I1 and I2, you will understand better. So I am taking in the first case I1, that is I. In the second case I am taking I2, that is 2I. So in the first case it is H1 is equal to I square I1 square R T1, which is nothing but I square R T as it is. But in the second case H2, what happens? Current is doubled. So in the place of I2, it is formula I2 square R T2. I2 square R T2 in the second case. What is I2? I2 means 2I whole square because it is doubled into R is same. Time is half. So what happens here? It becomes 4I square R into T by 2. So what happens here? This 2 ones are 2 2s are we can cancel. We get 2 times I square RT, which is nothing but 2 times I square RT is nothing but H1 only. So we got H2 is equal to 2H1. So this is what case study question, one of the case study question. And here in this another question is also there, or question. A fuse wire melts at 5 amperes. A fuse wire melts at 5 amperes. It is desired that the fuse wire of same material melt at 10 amperes. Find the new radius. So everything should be same, only the radius of wire should be changed such that in the second case till 5 amperes it will not melt. In the first case at 5 amperes it will melt. In the second case till 10 amperes it will melt. So what? Heat produced will be same, at same heat is same. Let us take H1 and H2 in both the cases, but H1 is equal to H2. At the same amount of heat it will starts melting. Formula is what? I square R1 T1. But here you can take I value same and T value same because they are not affected. Oh, I value is changed. I1 square R1, time is same. Here H2 I2 square R2 T. So here what happened? H1 is equal to H2 we have to take. and R1 we have a formula resistance, there is a formula rho into L by A, where A is equal to pi r square, because question is related to radius. So in this way H is equal to I square RT, but R is rho into L by A. Again A is what? Pi r square, because we need resistance. So in that way we have to connect I square RT from this. R is rho into L by A, again A is pi r square. Here from this we are getting R in this. So here what happens? H1 is equal to H2, HT. So what we get? I1 square R1T is equal to I2 square R2T. In both we can cancel TT first. Then I1 value is given 5 amperes, 5 square into R1 formula rho into L by pi R1 square is equal to I2 is what? 10, 10 square into R2 is what? Rho into L by pi R2 square. And you know there is no change in the length, so we can cancel length also. Length is cancelled, rho is also cancelled, resistivity pi is also cancelled. Then what we got here? 25 by R1 square is equal to 100 by R2 square. Now we have to do cross multiplication to get the relation. 25 R2 square is equal to 100 R1 square. Now after cancellation, 25 ones are 25 fours are. So what we got here? R2 square is equal to 4R1 square. Apply square root on both the sides, we get R2 is equal to 2R1. So what must be done if you want current to be doubled? If you want current to be doubled, then radius also it must be doubled, so that same amount of heat will be produced, so that it will melt. So this is about electricity numericals. Hope you will understand. Hope you understood all this. If it is really helping you, comment which topic you want, which part you want. Especially numericals, most of the students they face problem. Only numericals will try to upload in the next class. Light also important concept for numericals and electricity also. Thank you.